Welcome to Hexagon Tutorials Dart series. Let's dive into streams in Dart and understand how they help handle continuous data over time. So, let's talk about streams in Dart. Streams allow us to work with a sequence of asynchronous events over time. Think of it like a pipe that keeps delivering data little by little as it becomes available. Now, unlike futures, which give us just one value and then they're done, streams are different. They can keep sending multiple values over a period of time. And this is super useful when you're dealing with real-time data like chat messages, sensor readings, or live stock market updates. So why exactly do we need streams? Well, imagine trying to handle a continuous flow of data using futures. It wouldn't really work. Futures are great when you're expecting one value, like fetching data from an API once. But when you're expecting a series of updates, that's when streams step in. They help you listen to changes as they happen and react to them in real time. That's the power of streams in Dart. Now let's talk about the two main types of streams in Dart and when to use them. First, we have single subscription streams. This is the default type of stream in Dart. You can think of it like a one-time delivery. It can only be listened to once. As soon as a listener subscribes, the stream starts sending data. If you try to add another listener, it'll throw an error. This type of stream is best suited for operations like reading a file or handling a single HTTP request where only one consumer is needed. The second type is the broadcast stream. This type of stream allows multiple listeners at the same time. It's like a live radio broadcast. Anyone can tune in, anytime, and receive the data as it comes in. Broadcast streams are perfect for UI events like button presses or real-time updates where different parts of the app need to listen to the same event source. So remember, use single subscription streams when only one listener is expected. Use broadcast streams when you want to notify multiple listeners. Understanding the difference will help you structure your code more efficiently in real-world apps. Let's take a look at this example to understand how streams work in Dart. We've defined a function called numberStream, and it returns a stream of integers. Notice the syntax, async asterisk. This tells Dart that this function will return a stream and emit values over time. Inside the function, we're using a for loop that runs from 1 to 5. For each number, there's a delay of 1 second using a waitFuture.delay. Then we use the yield keyword to send out each number into the stream. So what's happening here is, instead of returning all the numbers at once, we're sending them out one by one with a delay, just like a timer ticking every second. Now in the main function, we call numberStream and assign it to a variable called stream. Then we listen to the stream using .listen, and inside that, we simply print the received value. So when this program runs, you'll see the output, each printed 1 second apart, because the stream is emitting values asynchronously over time. This is a simple example of how streams let you handle a continuous flow of data in Dart. Let me know if you want this formatted for a slide as well. In this example, we're generating a stream of numbers from 1 to 5 using an async asterisk function. Each number is delayed by 1 second using future.delay and then emitted using yield. In the main function, we listen to this stream. But before that, we use .map to transform each number into a string like number 1, number 2, and so on. Finally, .listen prints each transformed value as it arrives. This shows how we can use streams to handle asynchronous sequences and use map to format or modify the data before using it. Let's talk about broadcast streams in Dart. By default, a stream in Dart can only be listened to once. This works fine for simple cases, but what if you want multiple parts of your app to listen to the same stream? That's where broadcast streams come in. A broadcast stream allows multiple listeners to subscribe to it. It's really useful when you're dealing with shared events like UI interactions, live data updates, or app-wide notifications. To create one, you simply convert a regular stream using the .asBroadcastStream method. So, whenever you need to share data with multiple listeners, use a broadcast stream. In this code, we're defining a function called numberStream, which uses stream.periodic to generate a new number every second. It emits values starting from 0, 1 at a time, and stops after sending 5 values thanks to the .take method. Now here's the important part. We want multiple listeners to receive the same stream of data. By default, Dart streams only support a single listener. So, we convert it into a broadcast stream using asBroadcastStream. Once it becomes a broadcast stream, we add two listeners, both listener 1 and listener, to start receiving the data simultaneously as it's being emitted every second. So in the output, you'll see both listeners reacting to the same values in real time. This is how you use broadcast streams when you want to share a stream of events with multiple subscribers. Let's talk about stream management in Dart and how streams power real-time updates in our apps. Streams for real-time data updates. Streams give us a way to handle continuous data flows, which means our app can respond to changes as they happen, whether it's a live feed, sensor data, or user interactions in real time. Using listen. To start receiving data from a stream, we use the listen method. It sets up a listener that waits for new data and responds whenever something new arrives. Error and completion handling. It's important to manage what happens if something goes wrong. That's where onError comes in. It helps us catch and handle any issues. And when the stream finishes sending data, onIn tells us the stream has completed. Stream transformations with map. We can also transform stream data using the map function. This lets us change or format the incoming data before it reaches the listener, giving us more control and flexibility. Broadcasting streams. By default, a stream can only be listened to once. But if we need multiple parts of the app to listen at the same time, we convert it into a broadcast stream. That way, multiple subscribers can receive the same data without conflicts. We've already covered Dart's type system earlier, so let's quickly recap what we've learned. Dart is a statically typed language, which means it checks types at compile time, helping us catch errors before the app even runs. We use common types like int for whole numbers, double for decimals, string for text, bool for true or false values, list and map for collections. You can explicitly declare a variable's type like int age is equal to 25, or let Dart in for the type using var or final. So overall, Dart's type system makes your code safe, predictable, and much easier to maintain. So, we've seen that Dart has a strong type system. We can define variables as int, string, bool, and so on. But here's the thing. What if we're working with collections like list, map, or even our own custom classes, and we want to specify what type of data they should hold? That's where generics come into the picture. So in short, The type system tells what a value is, but generics tell what types are allowed inside a structure or component. Generics allow you to write code that works with multiple types while still making sure everything stays type-safe. In other words, your code becomes flexible, but without losing the benefits of Dart's type checking. Rather than writing the same function or class for each data type, you can write one generic solution that works across different types. Simple, reusable, and safe. Let's talk about why we use generics. Type safety. Dart catches type errors at compile time, not at runtime. So if you accidentally pass in the wrong type, your code won't even compile. And that's a good thing. Code reusability. You write your logic once and use it with any data type, integers, strings, custom objects, anything. And finally, cleaner code. You avoid repetition, reduce the need for typecasting, and your code becomes easier to maintain and understand. In short, generics make your code safer, more reusable, and a lot cleaner. And they're an essential part of writing scalable Dart applications. Let's go through what's happening here. I start with a list that contains mixed types, a string, a number, and a boolean. Then, I use a loop to print the length of each item in the list. As soon as I run this, Dart throws an error. That's because not every item in the list has a .length property. Strings do, but numbers and booleans don't, and that causes the error. To fix this, I comment out the original list and rewrite it using a generic type. I specify that this list will only contain strings. Now, since every item is a string, Dart knows that it's safe to call .length on each one. When I run the code again, it works perfectly. So, by using generics, I make the code more type-safe, avoid runtime errors, and keep it clean and reliable. Now let's understand how generics work with a class in Dart. We start by defining a class called box, and notice the T next to it. This is a generic type parameter. It means the box class can work with any type that we specify later. It could be int, string, or even a custom class. Inside the class, we declare a variable content of type T, and we initialize it through the constructor. Then we have a method called displayContent, which simply prints the value of the content. In the main function, we create two boxes. The first one, int box, is a box int. It stores an integer 123. The second one, string box, is a box string. It stores the string hexagon. We then call displayContent on both, and it prints the values inside each box. So, the key takeaway here is, by using generics, we've written a single class that works for multiple types, while still keeping it type-safe and reusable. Now let's look at another great use of generics, using multiple generic types in a class. We've created a class called pair, and this time it takes two generic type parameters k, v. Here, k represents the type of the key, and v represents the type of the value. Inside the class, we have two variables key and value, which are initialized through the constructor. Then we have a method display, which simply prints the key and value in a nice key-value format. In the main function, we create two instances of the pair class. Pair 1 is a pair string int, where the key is a string age and the value is an integer 25. Pair 2 is a pair int string, where the key is an integer 1 and the value is the string Dart. We then call the display method on both pairs, and it outputs the data accordingly. So, using multiple generics like this makes your class more flexible and reusable across different data types, and all without compromising on type safety. Now let's look at how we can use generics with functions. We have a function called printlist, and notice the angle brackets T right after the function name. This means the function is generic. It can accept a list of any type. Inside the function, we take a parameter called items of type list T. That means the list can be a list of integers, strings, or even custom objects, anything, as long as we define the type when calling it. We then use a simple for loop to print each item in the list. In the main function, we call printlist int and pass in a list of integers 1, 2, 3. Then we call printlist string and pass in a list of strings a, b, c. So with just one generic function, we are able to reuse the same logic for different types of data. And that's the real power of generics. Now let's explore generics with class constraints in Dart. We start with a base class called shape, which has a method called draw. This method is meant to be overridden by other shapes. Next, we define two classes, circle and square, and both extend the shape class. They override the draw method to print their own specific messages, drawing a circle and drawing a square. Now, here's where the generic constraint comes into play. We create a generic class shapeDraw T extends shape. This means the type T must be a subclass of shape. So we can't just pass in any type. It has to be something that inherits from shape. The shapeDraw class has a method called render, which simply calls the draw method of the shape it holds. In the main function, we create two instances, circle draw using shapeDraw circle, and square draw using shapeDraw a square. When we call render on each, they execute the overridden draw method from their respective classes. This approach makes your code both flexible and safe. You can use any shape as long as it extends the shape class. Perfect example of generic constraints in action. Let's now take a look at some of Dart's built-in generic classes, the ones we use almost every day without even thinking about it. First up, we have list T. A list is simply a collection of items of the same type. By specifying the type inside angle brackets, like list int or list string, Dart ensures that only values of that type can be added. This makes your code more reliable and prevents type-related bugs. Next, there's set T. A set works similarly to a list, but it doesn't allow duplicates. Again, we specify the type to make sure the set holds only consistent data, like set string for a group of tags. Then we have map k, v. This is used when we want to store data in key-value pairs. For example, map string int could represent subjects as keys and their marks as values. Here, k is the type for keys and v is the type for values. Finally, there's future t. This represents an asynchronous operation that will eventually return a value of type t. So if a function returns a future string, Dart knows the result will eventually be a string, even if it comes after a delay. So to wrap it up, these built-in generic classes, list, set, map, and future help us write type-safe, reusable, and clean code, while also giving Dart the flexibility to work with any kind of data. Let's take a moment to recap everything we've learned about generics in Dart. White heavy checkmark first, we explored what generics are and why they're so important. Generics allow us to write code that can work with different data types while maintaining type safety. Instead of writing the same logic multiple times for different types, we create a single, reusable solution. This not only saves time, but also prevents runtime errors by catching type mismatches at compile time. White heavy checkmark then, we looked at how to create generic classes. We built examples like box T, which can store any type of value, and pair K, V, a class that holds a key-value pair. These examples showed how generic classes make our code cleaner, reusable, and more flexible. White heavy checkmark next, we moved on to writing generic methods. We wrote a method like printlist_t, which can take a list of any type and print its items. This demonstrates how generics help us perform actions on data without worrying about the specific type involved. White heavy checkmark lastly, we introduced the concept of bounded generics. This means we can restrict a generic type to a certain base class. For example, Using t-extends shape ensures that only subclass of shape can be used. This approach improves type safety while still giving us flexibility. So overall, generics help us write robust, reusable, and safer code, making our Dart applications more scalable and efficient. Let's talk about one of the most important features introduced in Dart, null safety. Before null safety, variables in Dart could accidentally hold null values even when we didn't intend them to. This led to unexpected runtime errors, especially when trying to access properties or methods on a null object. But with Dart's null safety, those risks are significantly reduced. Null safety means that variables can't contain null unless we explicitly allow them to. This gives us more control and reduces the chances of our apps crashing due to null reference errors. Next, we have non-nullable variables. These are variables that must always contain a valid, non-null value. If we try to declare such a variable without initializing it, the compiler will give us an error. This ensures that we don't accidentally leave important data undefined. On the other hand, nullable variables are variables that can hold null if needed. We indicate them using a question mark, for example, string name. This tells the compiler that the variable may or may not hold a value, and we'll handle that appropriately in the code. Dart's compiler also performs compile time checks. This means that any potential null-related issue is caught while we are writing the code rather than showing up later during execution. These early warnings help us fix issues before they become real bugs. And finally, all of this leads to enhanced code reliability. With null safety, our code becomes more predictable, easier to maintain, and less likely to fail unexpectedly. It helps enforce correct usage of variables across the entire project. So, in short, Dart's null safety is not just a nice-to-have feature, it's a major step toward building robust, error-free applications. In Dart, understanding the difference between non-nullable and nullable types is crucial for writing safe and reliable code. Let's start with non-nullable types. These types are considered safe from null, which means the compiler ensures they will never hold a null value. This makes your code more predictable. And the answer is yes, non-nullable types must be initialized. If you declare a non-nullable variable, you have to assign it a valid value right away, or you'll get a compile time error. This requirement helps prevent a whole class of bugs caused by uninitialized variables. Now let's look at nullable types. These types are the ones that can hold a null value. You declare them using after the type, for example, string name. Because nullable variables can be null, they require null checks before you access their properties or use them in expressions. This is Dart's way of making sure you're consciously handling the possibility of a missing value. So in summary, with non-nullable types, you get safety and simplicity, but you must always provide a value. With nullable types, you get flexibility, but you have to be cautious and handle null cases properly. The key takeaway here: choose types wisely to ensure safer Dart coding. Decide whether a variable truly needs to hold a null value, and if not, keep it non-nullable for better code reliability. Let's briefly go over 3 scenarios to understand Dart's null safety. First, I declare a string variable and give it the value hexagon. Since it's non-nullable, Dart is happy, and it prints hexagon without any issue. Next, I try declaring the same non-nullable variable without a value. Dart immediately flags this as an error because every non-nullable variable must be initialized. Finally, I modify the declaration to make the variable nullable by adding a question mark. Now Dart allows the variable to hold null, and when I run it, it prints null. This progression shows us how Dart ensures safety by requiring non-nullable types to always have a valid value, while nullable types give us the flexibility to have variables that can be empty. Alright, let's start with a simple example. I declare a variable name as a non-nullable string and assign it the value hexagon. Then, I print name.length. Everything works fine. Dart has no problem here because the variable is non-nullable and already initialized. Now, let's make a small change. I remove the value and just write string name. Notice I also add a question mark to make it a nullable string. Then I try to print name.length. But this time, Dart gives an error. Why? Because name is null by default, and I'm trying to access a property on a null value that's not allowed. So, how can we fix this? One way is to use the null assertion operator, the exclamation mark. I update the print statement to print name.length. Now I'm telling Dart, trust me, name is not null. But the truth is, name is null, and this causes a runtime error. So the takeaway here is, even if you mark a variable as nullable, you have to be very careful when accessing its properties. Always make sure it's not null, or handle it safely with conditions or null-aware operators. In Dart, non-nullable variables must be initialized at the time of declaration. If you try to declare a variable without assigning it a value, like a string, it will throw a compile time error. To fix this, Dart provides the late keyword. This tells the compiler, I promise I'll assign this variable before using it. Using late allows you to delay the initialization while keeping the variable non-nullable. This way, your code can run smoothly without errors. So here, I've declared a nullable string variable called name. At first, I didn't assign any value to it. So when I printed it using the null-aware operator, Dart gave me the fallback, hexagon. Let's update the same variable and assign it the value hello. Now when I print it, since name is no longer null, it simply prints hello and skips the fallback. That's the power of the null coalescing operator. It checks for null and gives you a default only when needed. Alright, so here I've got a nullable string variable called username, but I haven't assigned it any value yet, so it's null. Now, I'm using the is equal to operator, which means only assign this value if the variable is currently null. Since username is null at this point, Dart assigns it the value hexagon. And when we print it, yep, it shows hexagon. This operator is super handy when you want to set a default value only if nothing's been assigned yet. Let's quickly go over some of Dart's null safety features. First up, nullable type marked with A. This allows a variable to hold a null value. For example, string, name, next, the non-null assertion, using. This tells Dart, I know this value isn't null, so go ahead and use it. But be careful, if it is null, your app will crash. Then we have late initialization with the late keyword. This is used when you want to declare a non-nullable variable. But assign it later, just make sure it's definitely set before using it. Now on to the null coalescing operator, which is, it gives you a fallback value when something is null, like var x is equal to name, guessed, and finally, the null-aware assignment, written as, is equal to. This one sets a value only if the variable is currently null. So for example, username is equal to hexagon. These tools together help you write safer, more predictable Dart code. Let's quickly recap what we've learned about null safety in Dart. So, what is null safety? Simply put, null safety makes sure that you don't run into those dreaded null reference errors when your app is running. It prevents null issues at compile time, meaning Dart checks everything before your app even runs. It also ensures that all your variables are initialized before you use them, so you don't accidentally try to use something that's not set yet. This all leads to safer and more reliable apps. Now, why is this important? First, it helps you catch bugs early in the development process. Instead of running your app and finding issues later, null safety makes sure you're good to go before you hit run. Second, it makes your code cleaner and more readable. This is a huge benefit for you and your team, especially in larger projects. And lastly, Null Safety boosts your app stability and performance, ensuring a smoother experience for users. So, to wrap it up, Null Safety is a powerful tool that helps you write better, more reliable code. It reduces bugs, makes your app more stable, and helps your code stay clean and easy to maintain. Thanks for watching the video. Do like, share, and subscribe to our channel.